Welcome to this comprehensive guide on optimizing your Unity 3D games by replacing traditional instantiate and destroy methods with an efficient object pooling system for projectiles. Object pooling is a crucial design pattern in Unity, specifically engineered to enhance game performance by reusing objects rather than constantly creating and destroying them. This technique is particularly beneficial for projectiles, which are frequently spawned and removed from the game world, making them prime candidates for optimization. While Unity's instantiate and destroy methods are convenient, their repeated use can significantly impact performance, especially in games with many dynamic objects. These operations trigger garbage collection, cause memory fragmentation, and consume valuable CPU resources, leading to noticeable frame rate drops and stuttering gameplay. Object pooling directly addresses these issues by maintaining a pre-instantiated collection of objects, ready to be activated and deactivated as needed. When an object is no longer required, it's simply returned to this pool instead of being destroyed, making it immediately available for future use without the overhead of recreation. This approach drastically reduces the overhead associated with object creation and destruction, minimizing memory allocation and garbage collection, which results in smoother and more efficient gameplay. The primary benefits include reduced garbage collection, lower instantiation costs, significantly improved performance, and highly efficient resource management. Now, let's dive into a practical demonstration, starting with the code implementation in Visual Studio. We'll begin by creating a generic pool manager script, which will handle the core logic of our object pooling system. This manager will be responsible for initializing pools, retrieving objects, and returning them when they are no longer active. Here's the complete code for our pool manager class, designed to be generic and reusable across different object types. Notice the use of a queue for efficient object retrieval and a dictionary to manage multiple distinct pools. Next, let's look at the pooled object script, which will be attached to each object in our pool to manage its active state. This simple script ensures that when an object is deactivated, it correctly returns itself to its designated pool. Now, let's transition to the Unity 3D editor to set up our object pools. First, create an empty game object in your scene and name it Pool Manager. Attach the Pool Manager script we just created in Visual Studio to this new game object. Next, we need to define the specific pools we want to use. For projectiles, we'll create a pool for our bullet prefab. Drag your projectile prefab into the designated slot within the Pool Manager component in the inspector. Configure the initial size of the pool, which determines how many objects are pre-instantiated at the start of the game. Now, let's see how to use the pooled objects in your game logic. Instead of instantiate, we'll use Pool Manager, instance.getObject. Remember to activate the retrieved object and set its position and rotation as needed. When the projectile is no longer needed, instead of destroy, simply deactivate it to return it to the pool. This simple change is the core of object pooling, ensuring objects are reused efficiently. Here are some helpful tips for optimizing your object pooling system even further. First, ensure proper cleanup. When an object is returned to the pool, reset its state, such as velocity, health, or any other dynamic properties. Secondly, manage object lifetime effectively. Use timers or collision events to determine when an object should be returned to the pool. Caching components is another great tip. Instead of calling getComponent every time, cache references to frequently accessed components like rigid body or renderer. Consider preloading pools. For critical objects, instantiate a certain number of them at the start of the game to avoid any runtime hitches. Using scriptable objects for pool configurations can also streamline your workflow, allowing for easy management of multiple pool settings. Limit the maximum pool size to prevent excessive memory usage, especially for objects that might not always be in high demand. Finally, always monitor performance using the Unity Profiler to identify bottlenecks and confirm the effectiveness of your pooling strategy. Now, let's discuss some common mistakes to avoid when implementing object pooling. A frequent error is objects not being returned to the pool. This leads to memory leaks and defeats the purpose of pooling. Ensure every object that leaves the pool has a mechanism to return, whether through a timer, collision, or explicit call. Incorrect object initialization is another pitfall. Always reset an object state completely when it's retrieved from the pool. Failing to reset properties like position, rotation, velocity, or health can lead to unexpected behavior and bugs. Finally, be wary of memory leaks. While pooling reduces garbage collection, improper management can still lead to memory accumulation. Always double-check for unreleased references or subscriptions that might prevent objects from being truly available for reuse. By implementing object pooling correctly, you can significantly boost your Unity game's performance, providing a smoother and more enjoyable experience for players. Thank you for watching this guide. We hope this detailed explanation helps you optimize your Unity 3D projects effectively.